Hey everyone, in this video we're going to look at something called quadratic regression. Quadratic regression is where we take a set of data and we create a quadratic equation that models that data. And we're going to use a TI-84 to create that equation. This is also going to give us something called a correlation coefficient, also called R squared, that tells us how good our regression is. And then we're going to use that regression equation to make some predictions, a process called interpolation or extrapolation, depending on where we're making our prediction. But let's start by looking at a little basketball. So here we've got an image of a guy shooting a basketball, and this was filmed, and then the film was stopped and the path of the ball was traced out multiple times. So some nice little technological use here. But the question is, based off of what we see, will it go in? And so what happens is, in your mind, you kind of trace the path of the ball and you look at it and you think, well, maybe. But what we want to do is find some more mathematically accurate way of determining whether or not this thing will go in. So what we have to do is we have to do what's called modeling. We're going to fit an equation to this so that there is some equation that describes the path of the ball, and then use that equation to find out, will it in fact go in? And don't go making this any harder than it has to be. All we're doing is laying a grid, that is something that we would graph on, over top, and then we just graph the quadratic through there. And we know that this thing is going to be a parabola because we remember that all things under the influence of Earth's gravity, if we neglect air resistance, travel in a parabola. So we know this thing's going to move in the shape of a parabola, and if we draw out that parabola, we can see that this basketball will indeed go in. So that's pretty nifty. We want to take it even a step farther than just drawing the graph, though. Once I have the graph, you'll notice that on this graph I have the vertex right there. I have the y-intercept. I seemingly have everything I need to write an equation for this, and it turns out that we actually can. And this is that equation for the parabola that you see modeled on that. And the process of getting this equation is called a quadratic regression. So the quadratic regression takes our collection of data, in this case, all the points on the graph where the basketball was, and our regression will take all of that data and create an equation. So here our equation is y equals negative 0.1875x squared plus 1.5x plus 3. All this kind of makes sense. The y-intercept on this should be 3, and we see that that is in fact where it starts. If we were to use negative b over 2a, we would find the vertex is indeed at 4. So this fits our data quite nicely. This is a nice quadratic regression. And when we do one of these regressions, there's two results we're looking for. First, we want a quadratic equation, which is going to let us make predictions. And second, we want the correlation coefficient, which is also called R squared. So again, take a look at this. Correlation coefficient and R squared, those are the same thing. Two different names for the same thing. And R squared tells us how well our equation fits the data, and thus how good our predictions are going to be. The closer R squared is to 1, the better our prediction, and the better the quadratic equation represents the data. So if our R squared is like 0.998, that is extremely trustworthy. It's a very good regression for our data. If R squared is anything less than 0.7, it starts to be something where we want to take things with a grain of salt. Between 0.5 and 0.7 is okay, but not great. And then below 0.5 is really not so good at all. So we can use that to sort of make ourselves aware of what's going on. So now the hard part. So we've got to actually do this. We have to take the data and crunch all these numbers. The idea of this is simple. I mean, there's nothing overly complex about the idea that I just lay down a grid, get my points, and I just want to draw a quadratic through there and get its equation. However, there's a lot of stuff going behind the scenes that's a little difficult to deal with, so we want the calculator to deal with all of that. And here is how we make the calculator do this. Now this looks like a lot of instructions, partly because it is, but I'm going to walk you through it with an example and ask you to do an example at the same time. And if you remember when we did linear regression and exponential regression, this is really just the same thing, except we're going to select quadratic regression at the end instead of those other two. So the first thing we have to do is turn on the diagnostics, second catalog, diagnostic on, enter times 2. And what that does for us is that's going to allow us to view r squared. So here's what that looks like on the calculator. We're going to press the blue second key, and then 0 where you see catalog written in blue, and that brings up this. Now you can scroll all the way down through this, which is extraordinarily painful, or if you see these green letters, you can press the button that has the letter you're interested in, and it'll take you, in that case, directly to the D's. Now I can just use the arrows to find right there, diagnostic on, hit enter twice, and now I've turned on my diagnostics. This means that every time I run a regression, it will give me the correlation coefficient, r squared, so that I know what my data looks like. To enter the data, I'm going to press the stat button and then enter, because I want to edit my list. And that will bring up this situation where I can actually type in some numbers. We'll look at that in a second. And then when I want to do a quadratic regression, I'll press the stat button. I'm going to go over to the calc menu, which stands for calculate. And then right there, number 5, a quadratic regression. I'll hit enter. On your calculators, you may have to scroll down to where it says calculate, and it will give us what we need. So let's actually take a look at a real type of problem that you'll see for this. And just as we've had before, I have my example and you have your example, and I want us to work these simultaneously at the same time. So the first thing I need to do is turn my diagnostics on if you haven't done that already. So again, that's second, 0. We want to go down to the D's, look for diagnostic on, and then hit enter twice, and my diagnostics are turned on. Now we have this big old nasty chunk of data. I've got mine, you've got yours. So what we're going to do is we're going to press stat and select edit, so stat, enter. And now what we're going to do is we're just going to type in this list. You can use these arrow keys to navigate. You can also press enter when you're done to move down. If you ever need to clear one of these lists, all you'll do is you press the up button so that L1 or L2 is highlighted, and then press clear. Don't press delete. If you press delete, it will delete the whole list and now it's gone and you can't use it ever again. Press clear and it will clear out everything that's in that. So I'm going to go ahead and type in mine. You type in yours. Now that I have all that data typed in, I want to make sure these lists match. If one is longer than the other because I forgot a number, this process won't work, and so that would be bad. So I check and my lists do match. So now what I want to do is I want to find that equation for the curve of best fit, that curve being a parabola this go round. So what I'm going to do is I'm going to go back to the stats menu. So I press the stat button. Now I want to make a calculation, so I go over to calc, and this time I want 5, a quadratic regression. And if I hit enter, in your case, you'll probably have to scroll down to where it says calculate. I get this right here, and this tells me my equation, and you can see what form that is in. You are right, that is in standard form. Well done. And so what I can do now is I can come over here and say for part A, that my equation for the curve of best fit is y equals, and then a is negative 0.468. If you are not told otherwise, round after 3 decimal places. So 0.468x squared plus 4.111x. I know that's positive because over here b is positive. And then c would be minus 15.207. And so there's my equation. I'm asked, is this a good fit? And so I look at my r squared value. R squared is 0.883. And if you'll remember, I told you that anything that's over 0.7 is a pretty good fit. So I would say yes, it's got a good r squared value for making it fit. Part B asks me this. What is the value of the function when x equals 13.6? So for this one, this is called interpolation. So 13.6, notice that's kind of in the middle of the x values that I have for my data. So I'm wanting to know about what the y value would be for an x value that I don't have but is in the middle of this data. And all I have to do in order to do this, and this is straight up calculator work, is take that value, x is 13.6, and replace all the x's in the equation with it. And so I can just type that in directly into my calculator, no more work necessary. X is going to be 13.6, and then that's going to be squared, plus 4.11 times 13.6, and again, this is straight up calculator work. Don't make this more complicated than it should be. 0.207. The only thing you may want to do is you may want to write it down with that value substituted in if it helps you write it out better. Make sure you have the squared term right there. That's going to be something that some of you miss. And then I hit enter, and it gives it to me. So for part B, when x is 13.6, I can say that y would be negative 45.872. And if I look at it, this kind of makes sense for a possible value for 13. We see as we get closer to 18 that those numbers get more and more negative. And so negative 45 feels like a plausible number there. All right, for part C, all we have to do there is now substitute in, sorry, I lost my cursor there for a moment, 26.5. Now notice this is outside of our data. So this is making a prediction based off of something where we don't have any numbers to show us that, but it's still the same idea. I just substitute 26.5 in for x. And if I go over here, there's a nice trick for doing this. If I, on my calculator, press second enter, it will bring up the very last thing I typed in, and now all I have to do is replace that 13.6 with 26.5, and that will save me quite a bit of time in typing, which is quite handy. 26.5, we hit enter, and so the value at that point would be negative 234.9, excuse me, 945, just like that. And so when x is equal to 26, that's what we should get. Now I do find that number a little suspect because we're expecting this to come back around, but then data's not perfect. This is a 0.883 correlation, so stuff like that can happen. Part D, finally, we want to know the vertex of this function. And in order to find the vertex of this function, what we have to do is we have to use negative b over 2a to find the x-coordinate, and yay calculator, so I'm going to use negative b is 4.111, excuse me, and then divide that by 2 times a, which is negative 0.468. And so when I do that, I can see that the x-coordinate for the vertex is going to be 4.392. And so that makes my prediction for part C look a little better, because now we know that this should get bigger and that value that goes with 18.2 is kind of our weird one. Now in order to find the y-coordinate, I just have to substitute 4.392 back in for x, just like we did for those others. So if I press second enter now twice, it'll give me my original substitution back, and I can just put in 4.39, and now I need to insert my 2, just like that. And over here, 4.39, and then again insert that 2, and I find that the y value of the vertex would be negative 6.183. And there we go. I've now found everything I could ever want to find on this. Note that this is just a real complicated procedure to get a quadratic that fits through a set of data. So what I'm going to do now to close out this video is I'm going to show you very quickly what it should look like for your example, and that will be kind of sped up, but you can see how you did on that. Study up, know these procedures, use that study guide that's part of the printout there to your advantage, and good luck, my friends.